All right, now that we're going to go through examples of non-Mendelian genetics, it's just important for us to remember what is meant by Mendelian genetics, and those are what we've been doing with mono and dihybrid crosses. And with our mono and dihybrid crosses, each trait was determined by a single gene, okay, and with two alleles. So if we looked at pea color, okay, we had purple, remember, as the dominant, and then we had little p allele with the white flower color. And anytime we had that dominant allele, it would hide that recessive allele. So if we had the heterozygous individual or heterozygous genotype, it would always be a purple phenotype. So our non-Mendelian genetics, those rules do not apply. All right, so our aim with this is to explain incomplete dominance, which is what I'm going to go through in this video, and be able to solve for incomplete dominance problems. All right, for example, with incomplete dominance, there are some rules that we have to remember. With incomplete dominance, okay, one allele is not completely dominant over the other, all right? And so when we get a heterozygous individual, we get what we see as a blending, okay? So let's look at snapdragons. It's a great example of incomplete dominance. When we have two dominant alleles, okay, in this situation, two red alleles, we get what we expect, red flowers. When we have two white alleles, we get white flowers. But when we have the heterozygous individual, because it's a form of incomplete dominance, we get a blending, and one red and one white allele goes for an in-between phenotype, all right, which is pink in this situation. So with our example problem in our yellow packet, okay, if you want to look at that sample problem there, we're going to do this example problem, which is cross a red snapdragon with a pink snapdragon. So our red genotype is going to be two big R alleles, all right? And our pink snapdragon, remember, has one red allele and one white allele. So we cross it, and we look at our resulting offspring genotypes, all right? And our question that we want to answer here is how many offspring will be red? And once again, just a reminder that in order to get the red phenotype, all right, we need two big R alleles. So we have 2 out of 4, so 1/2 or 50%, okay, of the flowers are red. And then the other 50 would be pink. So with this incomplete dominance, once again, we see our parents. We would need 2 big R alleles, and then we would need 2 white alleles. And our Punnett square, we would get all resulting offspring that would have the heterozygous genotype, and incomplete dominance, that would be expressed as pink. All right, so our next incomplete dominance problem we're going to go through is curly and straight hair. So our curly, oops, got over here. If you have curly hair, you have 2 C alleles, all right? And if you have straight hair, there are 2 straight alleles. And then, once again, incomplete dominance is that you have an in-between phenotype. It's something in between. It's not straight, it's not curly. And in this situation, that in-between is wavy. All right, and once again, we get that with the heterozygous individual. So let's look at this problem. What's the probability that these parents will have a child with wavy hair? So we set up our Punnett square. All right, we have CS, and that means that first parent has wavy hair. And then we have a straight-haired parent. So our resulting, oops, mistake there. Go back. So our resulting offspring, all right, and the question that we need to answer here is what's the probability that these parents will have a child with wavy hair? And once again, wavy is the heterozygous individual, and we have a 50% chance of a child with wavy hair. All right, if you're still with me, one final problem. With this example, and I believe that this is from your yellow packet, once again, we're thinking incomplete dominance. So we have dark, medium, and light. So I'm going to give our dark, okay, 2 dark alleles, all right? And our other end of the continuum is light, and I'm going to give those 2 L alleles. But what we need to remember is in order to get medium, we don't want to give an entirely different allele. We just want 1 allele from the dark and 1 allele from the light. So our medium genotype is DL for our key there. All right, so now in our problem down here, we want to cross parents who both have medium eyebrows. And this is a funny problem because it oftentimes confuses students. So we have 2 medium eyebrow parents. And our resulting phenotypes with dark eyebrows, well, we've got 1 out of 4, or 25% of the offspring that will have dark eyebrows. There you go. Those are your incomplete dominance problems.